All right, hi everyone. This is the webinar on safe and comfortable indoor climates for now and beyond. What mixed mode ventilation can bring to the built environment. It is Thursday, October 29th. I want to preface this webinar by saying thank you so much for taking the time to join us today. There are a million different Zoom meetings going on out there, virtual meetings, conferences, kids, schools, so many things going on. So I want to take the time also to appreciate you for taking the time to participate with us on this webinar. The duration of the webinar today is going to be 45 minutes. We're going to have a little bit of Q&A. Here's just some tips and tricks to also check to make sure that you're on mute. Make sure to close down all applications that you have on your computer to have a really great experience. And then also we recommend, if you can, to use a fixed connection on your internet to make it a better experience and to not try to use Wi-Fi. We are going to have a Q&A at the end, so feel free to write your questions in the question poll now. One of my colleagues will be looking at the questions poll and might answer some of the general questions. If it's presenter specific, we might save that to the end. This webinar is going to be recorded, so you will also receive a recording of this afterwards. Let's get into it. So thank you everyone again. I am here today to be joined with two amazing gentlemen. I have Eric Fontaine from VanZelm Engineering, who is an associate. Eric has extensive experience in designing HVAC systems. He designs projects and also has management experience within new construction, expansion, and renovation for all types of facilities, including colleges, universities, corporate campuses, manufacturing, research facilities, labs, and power plants. Thank you, Eric. In addition to Eric, I've got Christopher Dameron from Dameron Architecture with us today. Christopher is an architect and a landscape designer. He is, in addition to that, also a principal and a founder of the firm Dameron Architecture. So Christopher founded the Brooklyn-based firm to make a connection between architecture and his ecological interests. He is an advocate for the use of natural systems in architecture and focusing on biophilic design. He's also interested in passive heating and cooling methods and materials reuse. He has design in a wide range of community-centric projects, both from urban landscapes to event spaces as well as residences. Thank you both for joining me today. My name is Mia Brondum. I'm from Windowmaster Clearline Incorporated, and I'm the North American Sales Director for this organization. I have been working within the built environment and sustainable built environment the past 5 years, and specifically spent the past 4 years really focusing on mixed mode and natural ventilation design. So here is us today. We want to get into a little bit of some different topics. We want to just before we start create some kind of high-level context for you all. We see as designers and also participants within the built space that there are changes happening, both within the requirements coming from a health and wellness and a productivity space, but also in regards to what the building occupants are actually requiring and asking about. So we find ourselves asking, is there a paradigm shift within the ventilation design within the industry? And if so, what is this going to look like, and how is this going to impact the requirements that design teams have? So with that being said, we've created these 6 discussion points that we're going to go through today. I've listed them on the slide here to the right. To go through all of them is what we're going to do today, but just high level, I want to list to begin with. We're going to start looking at how is a modern day commercial and a school facility being designed to provide safe and comfortable indoor climates. Then we're going to start to take a look at the current context that we're all within. How has COVID taken an impact on a toll on how we should be thinking about ventilation design? We're actually going to take a look at that on a research-based approach. And with that, we really want to probe at the question, is 100% air-conditioned design outdated, or how are we in that thinking? With that being said, we're then also going to take a look into how does this impact from an architectural perspective. How should architects and designers be thinking about this and interpreting these shifts that we do see that's data-based? And then what about taking it from a design perspective then to, well, what about our clients? You know, they do have quite a range of concerns with the changes that are happening. How do we think about that and address that within our design? And then also, we're going to specifically look at the application of natural and mixed mode ventilation and how that actually can be used in projects going forward. So the last two discussion points are going to be about evaluating and giving you all some tips about how to evaluate the use of that for your projects. And then also at the end, just wrap up with how do you discuss that with the people actually using these spaces that you're designing, that being the facilities team and the building occupants. But with that said, I am going to start off with handing the introduction to this webinar a little bit further to Eric, who is going to walk us through what is ventilation and just provide some context here.
Thank you, Mia. Yeah, I think as a general discussion point here, what we're talking about with ventilation design systems, how it impacts all of us, I think just an overview of what is ventilation, what are we talking about here, and both the purpose of this. So I pulled a couple definitions from ASHRAE 62.1, which is the ventilation document that ASHRAE puts out. So ventilation, it's the process of supplying air to or removing it from a space for the purpose of controlling air contaminant levels, humidity, temperatures within the space. So it's basically what we need to deliver in the breathing zone, what keeps everyone going, what makes them productive, happy, and go lucky. There's really two approaches on how to deliver this ventilation air to the space. You have natural ventilation and you have the mechanical ventilation means. Natural ventilation is obviously using direct outside air through the use of openings in doors, windows, or other openings in the building, could be louvers, but you do it naturally without the process of mechanically moving it. And on the flip side of that, obviously mechanical ventilation, it's providing ventilation through mechanical means, through a fan or an air handling unit or a blower to get it within the occupied space. So there's really two main methodologies of how to get that outside air, which is the benefit for everyone, into the building. So again, how do you deliver the required ventilation? So the ventilation is pretty, God, I apologize for some dogs there, but the ventilation being natural or mechanical, it can be brought into, obviously through the use of operable doors, windows, or louvers. And there are strict requirements in the mechanical code that tell you how much opening area is there to meet the requirements of the space. So in a natural ventilation mode, you have to have 4% of the floor area that area is being served. It's typically what the current findings are from the IMC to make sure that you're adequately ventilating the space naturally. In a mechanical ventilation mode, it looks at both the number of occupants and the type of space it is, as well as the area. So it's both a function of the number of people, the use, and the square footage. So for instance, in an office, you're required to deliver 5 CFM per square foot for every person in there, plus 0.06 CFM per an area. So it looks at both the number and how big the room is to make sure that the amount of ventilation being brought in is adequate for the space being served.
Hey, and we're all at home in some manner. It's okay, Eric. We'll continue to move. Sounds like you have a happy dog in the background. Yeah. All right.
So how were the ventilation systems originally thought of and delivered? So back in, it was really done naturally. So a lot of original buildings, even your residences, they're all done primarily, they were done with operable windows. So you would have operable windows that you would be utilized most likely spring through the fall. And then for the winter months, when you really couldn't open the window and you needed to condition the space, you had some form of perimeter heating. And these are just some examples that we've seen at some local colleges and universities where you have operable windows to the outside to make the occupants have that outdoor connection, which is very, very valuable in a naturally ventilated system to have that connection to outdoors. But then you also have the ability to temperature control the space through some use of whether it's hot water or steam radiations here that you see here. And over to the right is typically what we've seen in a lot of existing classrooms, and we'll get a little bit into that of how the effects of what is currently going on with the pandemic and how we're dealing with it. But again, a lot of classrooms back then just had a bunch of operable windows and some form of perimeter heat to meet the intent of what was going on in those spaces.
Great. So that provides us with some level of context. And Eric, one of the next discussion points that we decided to move into is then how is that modern day ventilation
Correct.
is provided.
Yep. So as we talked about, what was happening early is operable windows, and then they developed into some ducted ventilation systems that may have had an air blower that was connected to some outside air to circulate the ventilation. But in a modern, what we've been seeing more and more modern day today is the ventilation systems that are going in some of the projects that we've been dealing with have been 100% outside air ventilation units. Typically, they're coupled with some form of radiant heating and cooling. That could be a floor, a ceiling, or something to do the temperature control. But the ventilation is done through what we call a DOAS unit, dedicated outside air, with some form of energy recovery, because we're trying to keep it as low energy use as possible. But that unit is sized strictly whatever, if it's a mechanical ventilation system, which is primarily what we're talking about here, that's typically sized for what the ventilation load is for each particular space. So we would go by, we look at every single space, the occupant, the use, we come up with a number, and then that's what we would be delivering to every space. And it's only that. It's not used for 100% of the conditioning of the space. That's reserved for other means and methods. So the image on the left there, you'd have ventilation air that would come in. Again, it could be 40 CFM for a single person office typically, but then all the other heat loads and stuff within the space would be handled by either a radiant ceiling, a radiant floor. We're proposing and seeing a lot of it now is personal ceiling fans for occupant comfort and thermal control, which we'll talk about a little later. And also what we're also proposing in a lot of these spaces is the use of some form of an operable window. So when conditions are good outside, when the conditions are nice, it's between 50 and 70 degrees and it's comfortable and it's not raining, the mechanical ventilation system shuts off, and we're trying to use natural ventilation and actually taking that a step further and transitioning to a mixed mode, which we'll get to in a little bit, to satisfy those spaces. So we're saving energy, we're cutting off the mechanical part, but then we're utilizing the natural ventilation and its benefits for the entire system in a lot of projects. And it's becoming quite successful, and we're seeing it more and more in a lot of projects. And there's some great systems and capabilities out there to optimize that entire natural ventilation mixed mode system, which we'll get into in a little bit.
And Eric, what you're showing here on your screen is any type of commercial. Can you just highlight, is it also school facilities that you're seeing with this?
Yeah, this isn't just, we haven't just saying this is commercial office, or we've seen this at schools. We've done this in schools a lot. Obviously, when we're getting into renovations and stuff, it becomes a little bit more difficult because of ceiling height and availability to run ductwork. But some new schools renovations, we definitely seen these systems go in. They're very energy effective. They're very beneficial, great value for thermal comfort. And this just shows a little bit about when you're looking at those DOAS systems, we want to do what we can to minimize energy use. So we utilize heat recovery at all possible. And one of the most effective means of heat recovery when you don't have, I'd say where your exhaust stream isn't has any particulates or smells or all that, is to use a heat wheel. And you can get anywhere from, a minimum of 80% efficiency there. So it's taking in what you're bringing in for outside air, it's preconditioning it through the use of the energy wheel, and it's cutting down on what your energy impacts are to deliver the ventilation air to the space for temperature control.
So and this is our, I'm sorry.
Nope, go ahead.
Well, I was going to say this is you're saying you're seeing this in a lot of projects, but this is our modern day ventilation design. So what if we go to a context in which we're all facing and have been kind of grappling with, obviously this year is this next
It
point
is.
about how does our current situation and our general beginning introductory slide about, are we seeing some kind of not only a paradigm shift, but is that paradigm shift based off of regulatory requirements for changes within the ventilation industry? So I was wondering for this discussion point, if you could take us through what's listed here on this slide.
Sure. So to date, to my knowledge, there has not been any, I'll call it regulatory requirements for this. What has been done is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRAE. They have put out a few position papers. They're worldwide. They deal with systems, equipment, heating, ventilation equipment. They are the industry expert in ventilation and heating and cooling. They've developed a few position papers that they published, I think it was in April or May after the pandemic first hit. And they got into some quick research and they started figuring out, okay, how can we deal with this? What is the issue related to COVID and being an aerosol? How can it get transferred throughout HVAC systems? Because that's sort of the common, concern is if everyone is indoors and now you're looking at a lot of existing air systems potentially have the pathway of recirculation of, if someone is in the room and it's aerosol based, does it have the potential to keep being recirculated in the space and affect everyone? So they've done significant research. Like I said, they put out 2 position papers, and this is just a snippet from one of the position papers that they put out and ways to deal with this. And I have seen it in a few state documents that basically they came out and they made recommendations on behalf of what ASHRAE has put out of trying to help schools reopen safely, college universities reopen safely, and what can they do to sort of limit the effect of it. And obviously the first bullet here is increase outdoor air ventilation, because obviously they're trying to get dilution in there. So the more outdoor air that they can provide into a space, it's going to help expel anything that could be there in an aerosol. And one of the other options, which isn't in here, but they have recommended, is to get the outside air, it's either shut off your recirculation component within your unit or open up your window. So a lot of schools that we will see here, with the natural ventilation approach and operable windows, keep those windows open as much as possible. Try to get as much outside air and fresh air into the space as you can. The second biggest thing that they identified had to do with the level of filtration. And looking at the particle size and what can get captured, what can get recirculated through traditional HVAC filters, they've made the recommendation to provide minimum of a MERV 13 filter, which I believe captures up to 85%. It's 85% efficient. So the particle that COVID would be in an aerosol form would get captured within that filtration media and not become recirculated potentially into the space. And a couple other bullet points we'll just run through. Obviously, you want to keep the systems running as much as possible. Keep air circulation throughout the space. If you have issues where you don't have a ventilation system and you have operable windows, but say winter time's coming and it's tough to keep this conditions temperature-wise, one thing you can do instead of opening the windows is put in local portable air cleaners, HEPA filters. There's a lot of good filtration units on the market just to keep turning that air over within the rooms. And they are recommending, it's not on here, but it's basically about 6 air changes an hour is what they're looking for as an air turnover rate. Other ways to do it for filtration and ventilation control, filtration control, is they're talking about ultraviolet filters. That's an option too. It helps kill the virus. So in recirculating air systems, whatever particulates get captured in the photo, you can use UV light to disinfect it so that it wouldn't be transferred back into the space. Obviously, you want to do what you can to maintain proper temperature and humidity, depending on how it can live. And the one thing that is in here, which they did put in here, is, for instance, as the example given with the energy recovery wheel, what happens is it's transferring air from the return to the supply. So there is a potential for cross-contamination. So if you are dealing with 100% outside air ventilation system, what they are recommending is during this time, we may want to disable that energy recovery wheel, just so if any particles are coming back to get captured, they're not being transferred to the supply and then blown into there. So they're talking about bypassing ERV systems where possible that can potentially cross-contaminate. And a lot of times you can only do that if you could just shut off the wheel, but a lot of times we'll have a bypass damper around the energy wheel just to save some energy. So it would be opening that and disassembling the wheel.
So Eric, I know that you and your team within VanZelm have done some really interesting research on these two high-level points that you mentioned, which is focused on increasing and optimizing the ventilation, and also the next part is the filtration. So I want to ask you just to kind of describe a little bit about your research and some of your findings on these two overall topics.
Sure. So here, we've been involved with a number over the past summer and June through August on a lot of college university work that we do, trying to make the schools safe to reopen. And we've been undertaking a lot of existing studies and documentation of basically how are those systems performing? Are they meeting the ASHRAE guidelines? Can they get the adequate ventilation, air, and filtration levels to the space? So the next two slides are basically just a summary of what we've been finding. And this is just an example of a school that we just recently completed. And it was a survey of, we went through the entire facility. We looked at every single one of their existing spaces and the ventilation systems and how they're being served. And what we wanted to do was say, what's an easy way to figure out where are my problem areas if they have any. So obviously the spaces in red we identified on the right that right now they're occupied spaces, they're offices, they're classrooms, they're conference rooms and all that, but there's no mechanical ventilation throughout. Right now they only have operable windows, which for the spring, summer, fall is fine to do it, but then the issue becomes, and their concern is, what do you do in the winter? And we'll deal with that. The green represents that they actually currently have existing ventilation systems and they currently meet the IMC, the International Mechanical Code requirements for ventilation. Yellow or orange on my screen, it represents that they do have ventilation systems, but they're underventilated, which means they're not meeting the code. So there's a handful of spaces there throughout that have, those are primarily a lot of the classrooms that we found there that were installed with ventilation systems when they were built. They're currently underventilated, and that's something that they're looking at adjusting. And then basically blue would just mean that they have ventilation systems, but they only operate in the summer because that's how they get their air conditioning is through that. So in the winter, there is no ventilation, and that's an issue too. So a lot of what we're seeing is, and just for some context, the areas on the bottom here in green, those are actually newer buildings. So those were built to more modern building codes and the ventilation requirements, where everything that you see from sort of the red up on the second half of the page, those were old original buildings that they sort of just added on over time. So those were built years and years ago, and they, like I said, they really only have operable windows, and they are looking to start developing some path forward to get some mechanical ventilation systems in there to supplement the operable windows that they've been using.
So that's our ventilation study part of it, and then there's the other part was the filtration, right?
Correct. So the filtration was the other big component that ASHRAE wanted to look at, is to make sure that there's adequate filtration in any type of ventilation system here. And so we looked at three areas. One is, do you have filtration? Do you meet the MERV 13, or do you not meet the do you not meet MERV 13? And just in this example, the same the same set of buildings, the same ventilation units, it's close to probably 80% of the ventilation of the HVAC systems there currently are underfiltered. They either had a MERV 8, a MERV 6, a MERV 10, something but they did not meet the recommended standard right now. And that's an easy solution. And we actually found that throughout a lot of college and university applications, where most of the existing ventilation systems were nowhere near the MERV 13 rating. Most of them only had MERV 8 or less. And what we've been recommending and what ASHRAE recommended obviously is to reinstall and put in new MERV rating filters. And the good news is MERV 13 is available in multiple sizes, so you can put it in a 1-inch, a 2-inch, or a 4-inch deep filter, and it'll work. Obviously, the deeper the filter, the quicker it could potentially load up. It has a higher efficiency, so it's a little bit taxing on the maintenance. But most of the facilities that we're dealing with are understanding of that, and they're dealing with it. But a lot of them, again, it's just get the filtration level up to what's recommended, and it'll be a better condition for a lot of the existing systems. And even just a point of context, a lot of the newer ventilation systems that were installed didn't meet the requirement here, even for a new modern day ventilation. So it's just looking at that now to make sure that we can make that work.
And I know that from a lot of your all's research on these school projects that you guys have been working on, that there's so much of similar data in different projects. So if anybody's, of course, ever interested in talking to Eric more about all of the studies that VanZelm has done, of course, reach out to him, because their team has a lot of data-driven research on this. So thanks, Eric. I want to take it to more of an architectural perspective as well, because Christopher, Eric has pointed out a lot of really great, you know, things that can be updated, should be updated. There's data there. That we need to start making some changes. But what about from an architectural perspective? How does this probe your thinking and your approach to design from what Eric is saying?
Well, I think, thanks, Mia. I think what's really come to light during COVID-19 is that our buildings weren't breathing anymore. They weren't functioning the way they needed to for health. And what we advocate and what we've been thinking about even before this happened was, how do we get fresh air into a building in a natural way, and how do we reconnect to natural systems? And I think we could speak to the beyond part now, because it's been shown, and we call this biophilic design. It's an emerging discipline that's been emerging for a long time, and lots of people need to embrace it, I think. But it's about connection to natural systems, the idea that humans have evolved with nature. And so neurologically, psychologically, we're more comfortable when we feel fresh air in a building than we are with a mechanical system blowing a steady stream of regular air with the fan noise and various other things. And we need to get back to utilizing nature in our designs. And I think one of the things that we run up against is architecture as a discipline has more and more specialized away from, or has become pulled away from, the engineering aspect of it. So as soon as we learn to deal with aspects like sunlight, ventilation, the weather, in architecture, again, through the form of the building, through integrating and working with people like Eric from the very beginning to create the form of the buildings, we're going to be in a better place.
So really trying to utilize that integrated design process and not having it be a siloed procedure really sounds like something you're also advocating more, to integrate these natural approaches, huh?
Yeah, absolutely. I think it's the only way forward. I mean, we have all of this right here at our disposal, and I think the more we start from zero, as people standing in nature, the better off we'll be. And this is a couple of slides here just showing the idea of merging landscape and architecture, and again, to these biophilic principles of bringing plants inside the building and bringing buildings into landscape to really expose people to natural systems. And the project on the right is an event space in New York City. It's an urban garden and event space, and the concept was to bring people in the city to nature. And so we decided to use the natural ventilation or mixed mode ventilation in this building as an experiment and as a asset to the building.
And I know we have some more pictures here to describe that project as well.
Right, and I think one of the other health aspects that we haven't really touched on yet is CO2, and the buildup of CO2 in buildings can make people sleepy and tired, and in the metrics of unproductive. I think that a lot of businesses are probably interested in that aspect of it, but also just as a health thing, it's something we forget about when the windows are closed and sealed, that all the people in a space are breathing and creating CO2, and it's dragging everybody down at the end of the day. So opening the windows helps that. It's the oxygen comes in, and in this slide we're showing air coming through trees, producing oxygen, and not only do you have that visual connection and connection to the sound of the rustling leaves and the birds, but also the direct benefit, biological benefit of breathing oxygen and creating that in a city. And one of the things about this building also is that it's an event space on the interior, so there's a good portion of time where it needs to be mechanically ventilated for events to counteract the load of 100, 200 people in there dancing. It gets pretty hot. You need air conditioning, but for the majority of the time, it's really a big empty space when there aren't events going on or one or two people are walking through. You don't need mechanical ventilation necessarily. So we installed a mixed mode ventilation system that senses the indoor and outdoor temperature, precipitation, weather conditions, and CO2 levels, and it enables the windows and skylights to open and close to balance out these things without using the resources or the energy of the traditional system.
Was the use of the system the natural part of it? Has it been used more than what you anticipated, or has it met your expectations?
Yeah, it has, and I think part of it is, and in order to make something completely natural effective, is that you have to start with the sun, and it's about sizing, the envelope, making sure the envelope has the correct insulation values, but also sizing windows so the solar heat gain is not excessive. I think, you could have all of the open windows that you wanted, but if the wall is all glass and letting constant heat in, then you're battling the sun. So I think that was the first thing, is getting it correctly, the apertures of the building correctly sized so the heat didn't build up. But once we did that, we found most of the year, I think it's been in operation throughout the more milder parts of the year now. We're heading into the winter, and the air conditioning does not need to be on for the majority of the time. I should say it's not open yet for events, so that particular building, we haven't tested it under a heavy load of the dancers I was talking about.
Well, we've got a few more pictures here as well of the space.
Yeah, and I think that the other thing about this biophilia, and I guess I just wanted to point out that we're in the middle of the city here and creating a garden, and the aspects of natural ventilation have a lot to do with all of the other things we're talking about. They all go hand in hand with exposing people to nature and bring that into the city again.
But Christopher, I mean, you say that project that you just showed us is in the city. I know it's in downtown Brooklyn as well. You show these beautiful designs where it's very biophilic based, but it's still, it's in the city, it's in Brooklyn, it's close to New York. What about all of these concerns that we hear quite often, and which should be particularly pertinent to this project about what about pollution and noise, and do we really want to bring that downtown Brooklyn feel into the space and that pollution level? If you can give us some of your experiences here on how you talk to the design team and to the ownership of this building about that.
Right. Well, I think about this a lot, and the first thing I would say is that in Brooklyn, we also have Prospect Park, which is 500 acres of beautiful park, and the Atlantic Ocean and the East River. We have a lot of nature here already. We have birds and more than just rats and pigeons. There's a lot of nature here. When everything gets quieter, you can hear it. During COVID, we've had it seems like the birds are really loud, but they're no louder than usual. We just haven't had as many cars. And I guess the bigger question, and we could talk about the tolerance of the people inside the building, but the bigger question is, are we going to sacrifice progress in terms of getting natural ventilation into buildings and exposing people to that because there are other problems? And I think pollution is another problem. It's very real, and giving people the ability to close the windows is a great thing. But I don't think we can let that stand in the way of progressing on this front. So that's what I would say to the pollution aspect of it, and the noise. It's a city. I think I'm near the Brooklyn Bridge right now. I hear cars honking. I think in New York we're used to it. So, but I think noise is partly it depends on the interior activity, whether it's like a workplace or something that needs quiet. But also the tolerance for noise is really could be expanded in the same way tolerance for thermal comfort can be expanded by dressing appropriately for the outside weather and not necessarily for assuming that you're going to go into an air conditioned or perfectly conditioned space at 70 degrees.
So having that discussion around with the building occupants, the ownership about potential, using something called an adaptive thermal comfort, dressing for the seasons, and is that building going to occupy and move in that way as well? But Eric, I'm also curious from your perspective as an engineer, using systems such as mixed mode or natural ventilation, this whole idea of an operative temperature and what are we seeing there, and of course the other points that we have listed on this slide, if there's feedback that you have as well.
Yeah, I think what we've been seeing is a trend towards more of that being acceptable. We're currently looking at a lot of designs that are allowing for expanded temperature ranges. Utilizing natural ventilation more throughout the system, which we'll get into a little bit later. So knowing that you can still be comfortable at varying temperatures. It doesn't have to be 70 degrees year round in your office. You can, still be comfortable if it's 75 or 78 degrees. There's other ways to deal with that. It has to do with obviously humidity. It has to do with what you're wearing, as Chris alluded to. The clothing rating. Air movement, putting ceiling fans within spaces, it makes you more aware of what you're dealing with, allows you to expand your temperature range and be more comfortable more often. In terms of systems, like Chris mentioned, noise, the nice thing about utilizing a natural ventilation system is if you give someone a window, they're going to open it. We're finding out that a lot and more about that is it gives them that control over their environment. They have their own little office there. They can make it as warm or cold they want. It can open it whenever they want. But also, if something's happening outside in summer, they're mowing the lawn, it's the spring, it's allergy season, they then have the capability of shutting it. So it's not, no one is telling them when the window has to be open. If the system's automated and it opens, they can override it. That's the nice thing of modern day systems and technology, is you're giving everyone their own sense of control, and they can deal with everything related to that.
So having some kind of occupant override keypad, if you are using automated windows, is something that's also key, is what we're saying. And then just to round this off, is from our experience as well, is that it's also to kind of discuss these pains or concerns is also about, well, what kind of, if you are using natural ventilation or mixed mode, well, what kind of system are you specifying and wanting to use in a building, where there are technologies available in the market right now that are sensor based and also intelligent, based off of indoor climate measures of CO2, temperature, and relative humidity, but also based off of the exterior environments. So in our natural ventilation systems, we'll always put a weather station that reads temperature, relative humidity, wind speed, and wind direction. So also thinking about, how is the system designed? What kind of system are you going to use is important as well if you want to provide these intelligent systems in a project. So thank you both for your experience and input to that. I want to get to, we have about 5-6 more minutes left, but I want to get into these last 2 points about, well, how does the design team actually start to evaluate if this kind of mixed mode or natural ventilation is right for their project? Then to do that, Eric, I know you have some really interesting slides here just to briefly take us through a project where this was of course a consideration for you all at VanZelm.
Yeah, this we'll go, and yeah, time-wise we'll go through this fairly quickly, but we recently just got through a project, and it was a very collaborative design. We utilized the integrated design process throughout. We had us as the engineers, we had thermal comfort specialists, we had energy people there, we had the stakeholders, the owners, the users there, and the goal of this project was, when it was first being designed, they asked the question is, do we actually even need mechanical ventilation and cooling, or can we actually just do this entire building through natural means? And there was long meetings, discussions, and all that, but we actually went through and we developed a lot of these ideas that we could actually make this project successful. We could use natural ventilation throughout the entire portion of the entire year. And in the summer, we found out was only a handful of hours that we would be outside the ASHRAE thermal comfort range. So as part of the design comfort, it ultimately, in the end, I think with some of the potential stakeholders there, we ended up putting in a full mechanical ventilation system. But I think the way the sequences are written right now is we're basically letting that be second, sort of on the back burner. So it's really, step one is use natural ventilation as much as possible. And if the conditions inside get too much, only then and only then will we utilize the mechanical. So that was a definite transition in the train of thought of how an owner and a stakeholder was thinking. Normally it's just full air conditioning, go right ahead. But this was the complete opposite, which was a very nice paradigm shift. So we had a couple modes of operation, obviously how the building would function and operate in a full ventilation mode. And we have a very extravagant, we talked through how this would work with the users and sequences and overrides and system effect. And so obviously the first step in this was, it was nice because it was a tall building. We had some sort of natural stack effect there. All of the occupied spaces were outside along the perimeter. The inside was more of an atrium space. So it was very useful for the way the building was laid out, was to utilize a natural ventilation system. So, when the conditions are right, basically all the windows open. And I think here we ended up with almost all of the windows being automated, which is a little bit of a different approach than what we typically see. Sometimes we see them be more manual in public spaces, but here, to push the natural ventilation step in this project, we ended up going automated in most of the space, almost in all the spaces here. So obviously conditions are right, all the windows are open. And then once you start seeing the temperature and humidity and dew point in the spaces start to get elevated, we then transition to a mixed mode ventilation. So because this building had an atrium, we were required to have atrium smoke exhaust fans. So all of the air that was in the building had to get exhausted out of the same penthouse level in a atrium smoke event. So what we did is since the equipment was there for smoke control, we utilized that same equipment, the same fans, to use in a mixed mode ventilation. So as space temperature started to increase, what we did is we turned the fans on. We designed them to be operated at low speed, so they were quiet. They weren't ramping up to 100% speed. They were all on VFDs. So at times that the outdoor conditions were starting to get elevated, and you can still meet that comfort level with some, I'll call it advanced increase in airflow, air movement. We would turn on those fans, and then we would utilize the same openings and the same airflow movement, but in a mixed mode. And that would be the second slide there, that when we
Sure. And before I take to the second slide, Eric, if you could just briefly say if you can allude to where the project's located, so the attendees can understand maybe the climate, and if you can allude to what kind of project it is.
Yeah, so this project was located in New Hampshire, right at Dartmouth College.
So public, or at least
it is a northern climate, so yeah, this wasn't sort of down south where you have a lot of higher humidity. So this was a northern climate, heating dominated, but the energy calculation showed that we could almost meet the entire cooling and thermal comfort range with natural ventilation only, aside from a few hours in the summer, which was very promising. And so this sort of basically the fan assisted or mixed mode that we call it. Again, it's the same operable windows. They would open, and what we would do is just turn on those smoke exhaust fans at a low speed to induce the airflow through the room, keep the occupants comfortable. And we've done this on numerous projects. It's worked out well. But it does take some logic and thinking to how does this all get controlled from the user perspective? When do you enable it? When do you disable it? So the next slide here shows sort of what we've worked through, and this was one of our energy engineering firm helped developed along with us this sort of slide algorithm of what happens. How do you really think about this? So you look at outdoor conditions. Is it between a certain range? If it is, then you go to the next step. It's almost like a step function control sequence in there. So you would look at that. Is the conditions right? Do you have wind? Do you have rain? Should we open natural ventilation? Should we enable it? Should we not? If like Mia said, a lot of these systems nowadays get installed with full weather stations. So you're looking at rain, wind, direction. So what you don't want is have the windows open in a 20-mile-an-hour gust of wind, and now you got water on your office desk. You don't want to do that. So it looks at all those variables, and it's smart enough to say, yes, I should be in this mode, or no, I should be in mechanical ventilation mode. And that's part of what we work through with the stakeholders to make sure that they are fully understanding the design and the components within the system to make it function.
So speaking about the stakeholders, I want to wrap up with you guys and give your last feedback here. We have about 2 minutes. If you all could give us your experience in regards to how does a design team prepare their projects and facilities team, and who are the building occupants in the facilities team to use such a system. It doesn't necessarily have to be as sophisticated as the project that Eric you just described, but in general, using a building that maybe they're not used to previously, what are the things that you guys have found that works in past projects? And yeah, go ahead, Chris.
Yeah, maybe if I could start briefly. I think it's just getting buy-in and participation from the client early on, and ideally the people who will be the facilities managers. I mean, from an architect's perspective, you need people to believe in this, because this is not a common thing yet in America, at least. You need people to believe in and as the concept of it. And so once you have that, then you can bring everybody along together instead of relying on constantly having to sell this as an architect or an engineer to a client.
Yeah, I would agree with that. The biggest thing that we've seen is starting off when we're sort of getting into a new project is, and just have that charrette. What are your goals for this building? How do you want it to operate? How do you see the building use being done? Those are big questions that can help lead you one way or the other. And I think, from an energy perspective, natural ventilation systems are a big key over mechanical, obviously. Sometimes the mechanical wins, sometimes it's a combination of both. We've seen that on most all of our projects, depending on the type they are. And a lot of times when you get in that level, there's a lot of questions. Well, I haven't done this before in a building. And you go references, you go to site visits that have this installed, and then they actually see it. They talk to the facilities people, they talk to the people there, and they say, oh yeah, that's great, we love it, and all that. So there's a lot of early level, high level meetings, and it's just, the biggest thing is always keeping the stakeholders continuously involved throughout the design to make sure they fully understand what they're getting, because at the end of the day, if you turn a building over to someone and there's no information of how this works, it's an uphill battle from there. We've been through it on a few projects, and we're seeing more and more on these sort of highly sophisticated engineered buildings. We're actually pulling together what was called like a building manual. So they actually get to understand what are all the buttons and sensors on the wall, where's the overrides, where's my thermostat, how does it work, how do I turn my stuff on? So they're becoming more and more involved with the building and learning how to operate it and see it function.
And that seems so simple, right? Bringing and training the facilities team, but with new things, we have to think about that in our design as well. And how are we making sure that that is scoped into the timeline? I think that's a lot of really valuable things, and seeing the reference cases, taking, those who maybe have concerns or have questions, taking them to see a project where it's been a success that's similar to the one they're working on is crucial. But I want to thank you both so much for your time today and the input that you've given us. Very, very valuable. We are going to take some questions now, and if we run out of time, we have about 8 more minutes left. But if we run out of time, here is everybody's contact information listed on this slide. If we don't have the time to answer all the questions, we will also follow up and reply to you specifically in a direct email. So don't fret, your questions will be answered. But I'm going to pull up the question poll here and see what we have going on. Okay, let's see here. Hold on. I see some questions in the chat, but I'm having a little bit of an issue with opening the question box. Hold on. Just bear with me a minute here.
I'm able to see a couple that that I think Catherine posted.
Okay. Are you able to see some of the ones that maybe haven't been answered yet? Mine is not letting me.
The first one, how do I make sure the natural mixed mode ventilations work as intended? That's a very good one, and that's actually brings up a really key point. Is a lot of one of the biggest things that I can recommend when you're going through these systems, and a lot of modern day systems will benefit from this, is actually building, commissioning, and testing. I've been involved with projects before where we've utilized this this type of system, and it for whatever reason the testing and validation and verification just didn't happen, and when that turnover happened to the owner, they just unfortunately just didn't know that they have full capability of opening windows, and that there's a whole mode of operation here that they can utilize to shut down the mechanical ventilation system. So they were just mechanically ventilating the building 24/7, 365, and it was supposed to be a net zero energy building. And they look at me and they say, hey, what's going on here? How come I'm using so much energy? So building, commissioning, and testing and startup is a big component to help make sure that it's actually getting validated and functioning. And I know the system that I used up at the Dartmouth project that Mia is fully aware of, part of that is you get it commissioned and tested right from the beginning. So you know when it gets turned over, you have the validation that the system is actually working as intended. So that's a big recommendation there, is to make sure you're doing commissioning and testing and validating it at startup.
Eric, I also see, and Christopher, there's a question specifically from, sorry if I say the name incorrectly, Lauren Salem, who's asking about are window sensors, in parentheses, to shut off / modify HVAC systems required to be installed in California? What is the price upcharge for those window sensors? And I'm assuming this person is referring to some kind of on-off, like an actual kind of like a gate to make sure that if the windows are open, then they send a signal to the system.
Yes, so I can't speak to the cost. Obviously, that's more of a curtain wall window question. Maybe Christopher can do it. I may speak to that. But in most of the projects that we do, we always utilize a contact switch on the window. So in buildings that are both mechanically and have the natural ventilation or mixed mode sequence, we always do it so, like I said, the window has a contact switch. So whenever that window opens, the ventilation system and the cooling to that space shut off. So you're never doubling up on what you're trying to do. So you're never going to be mechanically ventilating the building or the space when the window is open. So we have that permissive in there. And a lot of projects that we do with that have ventilation only systems and radiant heating and cooling, most likely in cooling mode, is when that window contact switch opens, it shuts off the chill water flow, so you don't risk condensation. So you have that safety permissive built in within the control scheme. So that's typically how we would look at designing a space that has both mechanical and natural ventilation mode. As to the cost of the contact, I can't speak to that. Like I said, I don't know, Christopher, looking at some windows with contacts, I don't know if that's, I can't imagine it's much. It's a wiring point that goes into the BMS, I know that, and we can actually alarm. So if an occupant leaves a window open at night, we can actually send an alarm to the BMS so facilities knows to go shut the window. So there's some costs associated with that, but the actual contact, I'm not sure of.
Yeah, I think in my experience, it's about the programming in the BMS and the way the two systems interrelate, because there's so many variables where you can control this. I mean, you can have them come, you can have the windows open during the rain if you wanted to. I mean, you're not typically going to do that, but there are a lot of overrides and ways to make it conform with codes. And I'm assuming maybe in California, because you can't open the windows if the AC is on, that's why that is California specific question highlighted.
Yeah. But then there's also the point about if you use an operable window that has an actuator on it, then you're already kind of getting that checked off as well, because you're able to get the position feedback of the window, the interconnection to a BMS system, and you also have control of the window based off of, if you take it that step, it could be a window actuator that bases its movement modulated off of sensor and weather data. So it could be a manual window with some kind of window sensor to give a shut off signal or an on signal, or it could be an operable window where you use some kind of actuator to motorize the operation and the tie-in there as well.
Yes.
I should say also,
yeah.
Oh, sorry, but very quickly with the actuators, you know, sometimes we're not talking about the cooling or long-term cooling, that sometimes the actuators just sensing CO2 may open the windows for a minute at a time and then close. So it's not about opening a window, leaving it open for an hour or two. It could be really minimal. Even in the winter, when you want to flush out a building, that could happen simultaneously with the heating to the building's benefit.
Yeah, so modulated approach is based off of the seasonal changes, and it doesn't have to be open close. It can be these tiny little increments. Absolutely,
Right.
There's the technologies. As a last question, because we are running out of time, I just want to answer. Thomas has asked, have you explored mixed mode systems where active and passive cooling can work simultaneously?
We have looked at that. We have done some of that where you are able to keep, for instance, the ventilation system or the cooling system operating in conjunction with the operable window to expand the number of hours and the comfort range and get more hours of natural ventilation within a space. So we have looked at that. I will say our office has done that. Personally, we typically do the interlock, so it's either one or the other. But I know there has been a lot of experience and research done that you can utilize both together to help expand that thermal comfort range and get more hours.
And Thomas, you see Eric's contact information on the slide, so feel free to, of course, contact him directly and discuss that maybe a little bit further. We are out of time. We have hit the 1 hour mark. That flew by. Knew that was going to happen. If there's any other questions, feel free to post it here in the webinar. We will direct them to you in an email separately. But thank you, Eric. Thank you, Christopher. It was very, very insightful. Very much appreciate your time. And thank you, everyone out there, for participating and
Thank you.
listening in. We will send a recording and our contact information after this. So appreciate everyone and have a fantastic rest of your day. Bye, guys.
I know.
Bye.
Bye.